Alright, so I'm going to go through a couple of problems off of the Freaky Friday assignment that covered domain and range. What I'm going to do is I'm going to go through number 1, 2, and down here at the bottom, number 8, just so you guys have a variety. I'm going to go ahead and cut number 10 because, well, not everybody has a calculator, and these are range values. And when I made my key when we checked it in class, I was in a hurry and I miscalculated the numbers, so I'm going to cut number 10. Okay, anyway, looking at number 1, again this comes into whether or not a graph is continuous or discrete. In this situation, this will be a discrete graph. And what that's going to mean here is that for my domain and my range, I'm going to actually be writing the numbers for the domain and range. So for instance, the x values, an x value here would be -4. An x value here would be -2. This x value would be 0, 2, and 4. So I'm going to actually write out, here are my x values, -4, -2, 0, 2, and 4. And you would do the same thing for range, y values, and then you would write out whatever your y values are for those points. Okay, so that's discrete. The rest of the graphs that are on here are all continuous. So this would be an example of a continuous graph. It's connected from beginning to end. I could draw this graph without lifting my pen up. Alright, so for domain, again, left to right. So on the left side of this graph, at this point, I can see I have a -5. So that means that whenever I'm writing my inequalities, and again, these are always going to be facing the same direction, I'm going to start from left to right. Since my left value is -5, I'm going to write in here -5. Now I'm going to look for my right value. So left side, right side. Okay, so my number would be -2. -2. Now, both points are open. That means that I will not be writing an equal to part to this inequality. So there's from left to right. Now, from bottom to top on this graph, and I'm going to change colors just so that it stands out a little bit more. From bottom to top, that's how our range gets read. All right, so bottom here, that would be -4. So again, from bottom to top, -4. Inequalities are all going to face the same direction. Whoops, doing range. Okay. And my top value now is going to be there's the top of the graph. So draw over here to +4. Okay, -4 to +4. And again, both of the circles, both of the dots are open circles, so I'm not going to be writing equal to. So there's your domain and range for this continuous graph. Now, what I really wanted to show you guys is in the situation where you have an arrow, things change, because now if I were to try to write my domain on the left side of the graph, there is no number. So this graph, this arrow, meaning that this graph is just going to continue on in this direction. Well, where does that mean this graph starts? I can't draw a line where it starts. It's just going to keep going over here to the left. So that means I'm not going to have a number for the left side. I can keep writing x less than. Okay, and over here on the right side, I can say, all right, there's a point, that would be 0. So I can safely say that on the right side of the graph, 0 is my number. And that is a filled-in circle, so that means this will be equal to. So to kind of break it down, if you have 2 points, 1, 2, then you'll have 2 numbers, 1, 2. Here I've got just a single point, that means I'll have just a single number. Same thing for the range, from bottom to top, bottom to top. So at the bottom here, I definitely have a number I can use, -3. So -3 less than, that's equal to, because it's a solid dot, y. Now on the top, well, I'm in the same problem. Up here at the top, that arrow is just going to continue to go. There's not a line that I can draw where I can say, okay, this is where the function stops. So that means that I can't have a top number. So then, for your actual answer, what you'll be giving is just this simple inequality here. One number, one inequality sign. That's all it's going to need. I'm also going to talk just real quick about number 9 here, just because it's a little special. It has the arrows on both sides of the graph. Well, since from here, from number 8, you can see that this graph just continues on. It means it's not stopping. I can't have a number on the left side, so I don't have a number on the left. I don't have a number on the right. So what does that mean for my domain? Well, since this graph continues on left and right, I can say that it covers the whole axis. Since the x-axis, just keeps going on either side, well, that means that I'm going to be covering all the real numbers, because the graph extends as far as the x-axis will extend. You can say the same thing for the range, because on the bottom here, this arrow is just going to keep going out, and on the top here, this arrow is just going to keep going up. So I don't have a bottom and top, so bottom, there isn't one, top, there isn't one. So what we're looking at here is, again, the graph is covering everything up and everything down. Since the y-axis continues up and continues down, it's covering everything, so I'm calling it all real numbers, because it covers the whole axis. That's all I'm going to go over for domain and range. This assignment, again, is due on Monday.